Hello friends, welcome to Medicine of 101. After a long time, I'm gonna make again videos on the basis of physiology of the neuromuscular junctions. It's basically on the topic of the musculoskeletal systems. So before starting the topic, just we need to know the very basic concept regarding these things. So at first, I'm just taking normally a piece of the spinal cord just like this. Okay. Just like this, for example. So it's not the anatomical correct, but for understanding, I'm just saying it. Okay. From here we know there's the alpha fibers here responsible for the motor systems. Okay. Now the alpha fibers is here. Now whenever this alpha fibers is coming here, we have the terminal parts. Just like this is the perisynaptic membrane. Is the terminal parts of the neurons. Perisynaptic membrane. Perisynaptic membrane. And as it's neuromuscular, so definitely there should be a muscles. And for examples, I'm just taking it says a muscular cells. Okay. The main thing is the function for this is the contractions. Okay, muscular contraction. How it happens, the mechanisms I will just discuss here. So first of all, we know that for its whenever these things will be done, that will be done on by the what? This is like the postsynaptic membrane. Just name them postsynaptic membrane, same thing. And in between them there is the synaptic cleft. These regions is the synaptic cleft. Another thing, there will be a neurotransmitter that will help to pass the signals or the electric impulse from this presynaptic membranes to the muscular end. Okay. Now in these cases, we know that there will be formation of acetylcholine. Okay. And the acetylcholine is one type of the neurotransmitter that will help to pass the impulse from here to here. At first, we need to know how the acetylcholine is formed. So we know there is like the from the diet. From the diet, the choline we just eat from the diet, the choline that will come, that will be absorbed. After that, it will come to the extracellular fluid, extracellular here, this choline, and this choline will be taken by these receptors or this transporter, choline transporter here, that is present on this presynaptic membrane. Then this choline will come here. I am writing C for choline, and we know all that what the within the mitochondria for formations of what acetate or acetylcholine, whatever you can say, acetate. After that, this choline and this acetate will form the acetylcholine, and that will be stored in the form of a vesicle. The acetylcholine. Now this is the process how the acetylcholine is formed. So first thing is here that from the dietary systems we are taking the choline. This choline will come through these receptors or through this transporter within the presynaptic membrane. And from the mitochondria, we know the various types of the process like the TCA cycles, the glycolysis and the TCA cycles. In between them, there is intermediate product, that acetyl-CoA or acetate, whatever you can say, that will combine with it and that will form the acetylcholine. Okay. Now, how these things will come here and how the further processes will be done, I'll just discuss again. Now, let's have a larger diagram. Now the thing is here, I already said how the acetylcholine is formed. Is the vesicles where the acetylcholine is stored. Okay. Now whenever the action potential or impulse will come, like action potential will come up to here. At the time we'll see. At the time the one of the channel, there is like sodium channels. This sodium channel will be opened and this sodium ion influx will be done there. So there will be the sodium influx. Okay. Now whenever we will see there is this influx of the sodium, also the cations, whatever you can say. cation. At that time we will see there will be like the stimulations of, I mean there will be like what? Let's suppose the resting membrane potential, if it is like the release potential like minus 70 millivolt, from here whenever the influx of the positive or the cations there will be there, it will little bit what? Elevated for. At that time we'll see the voltage sensitive, the calcium channels, they will get open. The voltage sensitive calcium channels. This calcium channel will come here, and through this the calcium ions will be put inside. Okay. After that we will see for these things within the vesicles part, we will see just like these things. Okay. These are one kind of the protein. These are known as the synaptobrevin. Synaptobrevin. Now, there is one kind of the protein also in the membrane. And this protein is just like this, blocked. Okay. But this protein is known as syntaxin. Now, whenever there will be the influx of this calcium ions, that will go there. The first thing is there, that will just get bind with these things. Now the figure will be just like this. Now the calcium will be here, the calcium will be here. So as a result, we'll see the repulsion in between these two things. As a result, we'll see this will be just like this. Or in more simple diagram, I just can, after binding of the calcium, the figure will be just like this. Here will be calcium, here will be calcium. After that, we'll see this part will be attached with these proteins, and then with the membrane. Okay, after attaching with the membrane, there will be configuration changes, and this configuration changes is just like this. Then we will see the relations of the acetylcholine from here. Acetylcholine. Okay. Now the acetylcholine will come out. After that, we will see in this case just like this that there are the receptors. These are the muscular crests, and here there are the receptors for the acetylcholine. Now, if you see the structures of the acetylcholine receptors, just like this, is the pentamer. Now, in the both sides of these things, we will see there is the receptors for the acetylcholine. Okay, just like this. Let me draw here also. There will be receptors for the acetylcholine. Similarly, there will be also the receptors for the acetylcholine also. Now, in these both sides of this, the acetylcholine will get bind. Now, whenever the acetylcholine will get bind, as a result, we will see this pore. We are seeing this the block right now, but it will be opened. And we will see there will be influx of the cations, just like the sodium, within the muscles. Okay. Now, whenever the sodium is coming here, let's suppose before influx of the sodium, the resting membrane potential is minus 90 millivolt. So this was the RMP, or I am writing RMP stands for resting membrane potential. So whenever the sodium influx will be there, as a result we will see this minus 90 millivolt will be a little bit elevated. It may be minus 60 millivolt, minus 50. Okay. And it is known as EDD. After these things, okay, I am not writing these things, I will discuss these things in later. Minus 60 millivolt. And whenever this minus 60 millivolt, after that further it will go like just like the threshold, up to the threshold potential. And whenever it will go up to the threshold potential, at that time we'll see that voltage sensitive is like normal sodium. The receptor, the sodium is coming in for the activations of the acetylcholine receptors. But whenever this potential will go up to the threshold potential, at that time we will see there will be the activations or opening of the voltage sensitive sodium channels. Voltage sensitive, it's like the voltage sensitive. voltage sensitive sodium channels. As a result, we will see again there will be influx of the sodium within the muscles. Then this potential will go further. It will be like up to the neutralization, maybe plus 0, or it may be plus something like 5 millivolt. At that time, we'll see the voltage sensitive calcium channels that will get open. Voltage sensitive calcium channels that will get open. Okay. And whenever this calcium channels will get open, after that we will see this calcium influx will be there. Then this calcium will activate the various types of the process that will go to the sarcoplasmic reticulum and also, okay. Then that will just produce, the, we will discuss all the things later, like the actin myosin, troponin, tropomyosin, how these things are, occurring, all those things in these terms, circumstances. Now there will be these things, okay. Now I want to say one thing that whenever this acetylcholine will be there, that will come out. This acetylcholine will not act for longer. It's like these things. Because if the acetylcholine is just like this, if I just contract my hand just like this, then I can just relax like this. So acetylcholine is coming, I am contracting. Whenever the acetylcholine is getting destroyed, I am just relaxing my hand. So some for the muscular activities. So there is enzymes here in the synergetic cleft regions or the in these regions. So the name of the enzymes is like the acetylcholine esterase, acetylcholine esterase. That will break down the acetylcholine, and this acetylcholine may be reuptake again by these things, by the presynaptic membrane, and it can be utilized again, or it may be destroyed. These are all about the mechanisms of the neuromuscular junction, these things. Okay. Now the further processes, how the muscle contraction is done, like the actions of the actin myosin filaments and the troponin, tropomyosin, how the calcium is removing the marks from the troponin, troponin, how is removing the troponin from there, and how the myosin is getting attached with the actins, how the ATP is utilized there. Okay, we'll discuss all the things in the next subsequent videos. Okay, if you just new, please do subscribe my channels for the best concept ever you will see. It is related with the physiology. Thank you for watching.